Hello guys. Last time we saw how to run WordPress using AWS and their manager service. So today I thought we're gonna do it, we're gonna run it manually like this, creating every resource we need in AWS. So we're gonna see how to run WordPress in high availability mode, but this will be part of different tutorials. So I cannot explain everything in one tutorial, so we'll just spread across different tutorials. So today we're gonna start with basic stuff, basic knowledge of AWS, basic concepts, and we're gonna increase on this series and adding more and more complex and tools to run WordPress in high availability mode. Okay, so let's jump in the presentation. Okay, so here we have running WordPress from scratch on AWS. So we're gonna see the first part will be the networking, okay? Because the networking is very important. If you don't have a network right, your application might not run or just might get hacked or might just fail, okay? So the first concept in AWS, and it's very, very important concept, is the VPC, Virtual Private Cloud. So basically what is a VPC? A VPC is like a private isolated network. So you can imagine, for example, you buy routers and you connect them together and you leave it at your house. So these routers are connected together, there is a network, you created a network, but they have no access to the outside world. So it's private until you say so, until you connect it to your internet box, for example. VPC is used to launch AWS resources, so we can imagine EC2 instances, so it's just VMs, containers, and also Lambdas. You can also run Lambdas in VPC since 2017, 2016, don't remember. A VPC currently in AWS expands to only one region. So what are the regions? So the regions is a point where AWS is. So for example, if I look on the console, the regions is this list that you have here. So for example, North Virginia, where we are now, you have also like Ireland, London, Paris, etc., etc. So this is regions of AWS, okay? And within a region, there is availability zones. Availability zones is separate data centers for one region. So for example, if we take Ireland region, it has 3 availability zones. That means there is 3 data centers which are separated physically between each other. That means if, for example, I don't know, water flooding in one data center, but normally should not impact the other tools. For example, also if the internet connection, like a fiber connection, is cut to one data center, it should not impact the other tools also. And electrical power is the same. So that means if, I don't know, electricity got shut down because of storm or something like this, it might be that the other tools also are available. It's just not like a big storm, for example. Like I said, if it's not a big storm, but need to think also what happens if there is a big storm and all my data centers are shut down. Okay, so that means you need to have also multi-region concept, but we're gonna talk about that later on. And a VPC have a /16 CIDR range. So if you don't know what a CIDR range is basically the address of a network. Okay, so let's imagine a network is like a town. In this town there is various areas, okay, quarter 1, quarter 2, etc. And in each quarter, each area, there is houses, for example, with an address. So a CIDR range will be the town, a subnet will be the area, and IP address will be the address of your house or address of the house inside the town, okay? So now we have talked a little bit about subnets. Let's go in more in detail of this. So, like I said, here we have availability zones. Already talked about this. One thing also between availability zones, there is high traffic connection. So there is optical fibers that connect the availability zones of a region. So that means there is some latency between availability zones, but not so much. Okay, it's not like changing region or going over internet, because they have like private fibers that goes from one availability zone to another one. Okay, yeah, let's go with our subnets. So the subnets is used to segregate the resources. Okay, so like I said, areas in a town. So for example, there's area A, area B, and you can, I don't know, for example, let's say you have stores in area A and houses in area B, etc. One subnet can only be in one availability zone. Okay, VPC is across all availability zones, only one region, but a subnet is just one availability zone. So it means it's running on one data center. Okay, when you create a subnet by default, AWS takes 5 IP addresses. So you need to bear in mind which size you give to a subnet. If you give a very, very small size to a subnet, and you know that AWS is already taking 5 IP addresses, that means there is not much IP addresses left. Okay. And on a subnet, there is a routing table associated. That means how I go from area A to area B. For example, in my town, when I take a route. Okay, so this is the same thing for subnets. There is routing table. So it means to switch from one area to another, which route should I take? Okay, so the concept of private and public subnets, it depends actually on the route. So if you have a route that leaves the city, okay, that means it's a public subnet. It's a public area. It's an area that you can transit from one city to another one, okay? So by default on a VPC, there is no internet gateway. So that means you have no internet connection. Even if you create AWS instances, you will see that instances might have like a public IP address. So that means an address switchable from the internet, but you might still not have internet access. It's because in most of the cases, you don't have an internet gateway. An internet gateway says, okay, I can route my IP, my public IP addresses to the internet. Okay. Yeah. So the private subnet doesn't have a route directly to the internet gateway because they are private. So in order to make internet access available for the instances that are running on private subnets, you need to have a NAT gateway or NAT instance. Okay, so the difference between NAT gateways and NAT instances, NAT gateway is a managed service and it scales automatically. NAT instance is an instance, a VM that you install, you configure to do NAT. And wow, sometimes it can be cheaper if you have a lot of traffic, but I will really recommend to use NAT gateways. Okay. Okay. So routing tables. So you can associate a routing table to subnets, and you can only have one subnet, one routing table per subnet, okay? But you can have same routing table across different subnets. Okay, so for example here on the public subnet, it's the same from this one, there is a routing table that says if I want to go to internet, which is 0.0.0/0, I need to go to the internet gateway, okay? And if I need to talk only to the guys that are inside my VPC, I just do it locally. This is by default. The default route here is not set by default. Okay, so you need to remember when you add an internet gateway, you need to create this route on the public subnet. Otherwise, you will not have internet access. Okay, and for the private subnets, it's more or less the same. Instead of having the internet gateway here, you have a NAT gateway. And NAT gateway needs to be inside public subnet because NAT gateway needs to have like a public IP address where it can forward the traffic towards internet. Okay. So basically this is the same. We attach this private route to both subnets, and like this, all the instances in these subnets will have internet access. Okay, next slide. Security. So security is a big topic. So how do I prevent my instances to get traffic from an unknown source on the internet? So for example, let's say I open the port 22, which is SSH, and I don't want all the world to have access to SSH on my instances, which is quite normal. Actually, you should not do that at all, but it's an example. Well, you can use security groups, which applies directly to at the instance level. So actually, it's a hypervisor who does the checks of the security groups. Say, okay, this traffic, I will not allow it into to the virtual machine, so I will block at the hypervisor level. That means, for example, if you say, oh, I just want to have SSH access from my home, my IP address of my home, then you can just specify, I open the port 22 only to my IP address. And then there is network access control list, NACLs, we said. This operates at the subnet level. So let's say you will not reach the hypervisor when you use NACLs. It will be like internal inside AWS, and it will be at the router level that says, okay, I block this traffic. This is better for DDoS protection. So that means instead of going directly to the hypervisor, like say if you have like crazy amount of requests that does a DDoS attack, and you go to the hypervisor will fail and will crash. Okay, because you cannot handle that much traffic. But if you do at the router level, then the hypervisor will not be impacted. Maybe the router will be, but at least not the hypervisor, and your VM will still be running. Okay. So NACLs, you use it in very specific use case because they are stateless. That means if I allow one IP address, I allow my instance to communicate to one IP address, I need also to add a rule that says this IP address needs to communicate to my instance. Security groups are different. They are stateful. That means when I allow for my instance to communicate to one address, I don't need to add another rule that says this address can communicate with my instance. Or for example, if I say I can do SSH from my home to my instance, I don't need to say to my instance, to security group, that the instance can reply to me. It's automatically done because it's stateful. Okay. So where does our WordPress instance will be? So we're going to use one instance for WordPress for now. So we're going to place this instance inside a public subnet because we want to reach the instance from the internet, which is the main goal of WordPress, to have a website. And we're going to have an RDS also instance in a private subnet because we don't want the people to access our database. Okay. So the WordPress will put it in a AZB, and also for the same thing for the RDS. Like this, we don't have extra latency to change different AZs. But you can imagine like running RDS, the RDS instance inside a different AZ will not make a problem. Okay. Okay. Yeah, one thing also, it's for each instance you declare, each VM, you need to attach a disk. By default, when you do it via the console, you attach, I don't know, like 10 or 20 gigabytes disk. But you need to bear in mind that this disk can change in size and also can change in performances. That means if you have a lot of traffic, you want to have like very fast disk. And in Amazon, how do you have very fast disk? Well, you have two different kind of disk. I will not go much in detail this, you should read the documentation, but basically bigger is your disk, more performances you will get. Okay. Okay, so now we're gonna see in detail this. We're gonna use infrastructure as a code to deploy the infrastructure. Luckily for you, I already did it because it takes around 15 minutes to deploy it, and I don't want this to be in the video, but I will show you the steps that I use to deploy this code. And I'll show you also some interesting parts of the code. Of course, you need to know a little bit of Terraform, even if it's very easy to understand or to read, you still need to know a little bit of Terraform to understand it. Okay, so let's check first the console and then we go through the code. So here I am with the AWS console, and if we go to RDS, You can see I have one database instance which is deployed. Okay, and you see it here. I should be small, but we did that last time, so I will not go much in detail here. I'm gonna go also to the instance. So the instances, the VMs in AWS is called EC2. So let's go in EC2, and we see here that I have one instance running, and with a public IP address. I copy that for now. Okay, and the most important thing, the thing we will talk during this presentation, is the VPC. So the VPC, I created one VPC especially to run this WordPress instance with RTS. So it's called example VPC. Okay, I have a CIDR range of 10.0.0.0/16. Not much more to say about this VPC. There's subnets, but let's select first our VPC. Yeah, so here you can filter by VPC, so it's example VPC. And you can see here I have 4 different subnets, 2 privates and 2 publics on different AZs. You can see here the AZ is different. Just this is just the name, but if you look to the availability zone here, it is different. Okay. On this public subnets, there is routing tables associated, and you see the ID of a routing table, and you see exactly what I put on the slides, except with real IDs. So if I want to communicate to someone to my VPC, I go local, and if I want to go on internet, I go to the internet gateway, which is prefixed by EGW. Okay, and for the private one, I use the NAT gateway. Okay, so here you see it's well, yeah, we see it's private subnet here, and the routing table is just it's just a bit different. Okay, the NAT gateway is also here. It just created one before, but doesn't matter. And a NAT gateway, there is no much specific stuff. It's just there is one public IP address associated to the NAT gateway, and that's it. It's running after inside inside a subnet. You can see the subnet is the public AZ1, AZA, sorry. One thing here is, for example, in case of catastrophe, if you have like multiple AZs, but you have a NAT gateway inside one AZ. So let's go back to the slides. Let's go back to the slides. Here, you have a NAT gateway in one AZ here, but let's say this AZ fails because of flooding or storm, or because there is a electricity fail, okay? That means your NAT gateway disappears. So if you had instances here in the private subnet of the AZB that say that use this NAT gateway to go to the internet will fail. They will not have internet. So that means for high availability, what you want to do is to have a NAT gateway in each availability zone. We don't do that for this demonstration, but if you run production use cases with private instances that needs constant internet access, you should do that actually. We don't do it because, of course, there is a cost involved in creating a NAT gateway in each availability zone, and we don't extra cost for that. Okay, so we've seen most of the things here. Let's jump to the IP address. And here we continue with our super WordPress site. Username, let's create master 123. Okay, email master@gmail.com. I want to use a weak password. Okay. Okay, let's log in. Master. You see, it doesn't ask for database details. I will explain you why just in few seconds. So this is the password. 23. Okay. Don't need to remember me. Okay, here we have like access to our WordPress, and if we go to our WordPress website, we can see here it's running. Okay, so we got not much detail on this. It's just WordPress, and after you can do everything you want. Okay, so let's go to see the code. So on the same GitHub as the previous video, I will also put a link in the description. I have created a new folder which is 2 basic VPC, and in this folder there is a makefile which this time works, and there is a Terraform folder where all the infrastructure is declared. So if I go to VPC here, what I do, normally I use a VPC module for that, but for this course, I don't use the module because the module is hiding a lot of things, and it's better for you to understand how to create a VPC manually. But of course, the module does things better. You can look for in Google like Terraform VPC community module, and you will see it's the first one. And I strongly advise to use this one. But in order to understand how the different resources are created, I just created manually without this module. So first thing here, we have a VPC. Okay, so this is the way how we declare a VPC inside Terraform. There is a DHCP option set. I don't talk much about this. Maybe later on different video. This is the option set, DHCP option set association. Skip it for now. And here there is the subnets. Okay, so there is public subnets. Okay, public 2. On the AZ2 and private subnets. Okay, so on the public subnet you define which VPC you want to run it, which CIDR block, so which is the address which is the identifier of subnet. So here I use a variable, and which availability zone the subnet should be. Okay, and the same thing for all subnets. And then here I attach an internet gateway to my VPC. So you see this line, I define which VPC I need the internet gateway to be attached. Here's the NAT gateway, same thing, which subnet, which IP address. So NAT gateways use elastic IP addresses. That means you need to create one before you attach it to the NAT gateway. Okay. And here is the routing table. So here is where we make the subnet public or private, actually. So this here we have an example of a public route. So we have a default route, which is 0.0.0/0, goes to the internet gateway ID. Okay, and here we have a same thing for private, but instead of having the internet gateway, here we have the NAT gateway that makes the subnet private. And here is the association, associating the route tables to the subnets. Okay, so nothing fancy here. For the RDS, here I use a module. Actually, you can also run it manually. It's 2-3 resources, I think, in Terraform, but the module actually is quite nice, so I use this one. So you see here the address of the module. You can also look on Google, Terraform RDS module, and you will find it. I think it's the first one, which have more like stars in GitHub. And on this RDS, the particular thing that I do, it's here I select the subnet IDs and I choose the private subnets. Okay. On this module, you cannot specify only one. Well, I didn't find a way at least. Only one subnet when you create RDS, because normally RDS is highly available and needs to be on different availability zones. So I think this module doesn't allow you to run only on one AZ, but you can run RDS on only one AZ if you want. And I use MySQL like we saw on the different video. And here I have a security group which protects my database. And here I say I allow only the people from my VPC to communicate with my RDS. We could have went stronger than this, we could have said only my instance only have access to the AWS database. But for this example, we just did the VPC. Okay, and now we're gonna jump into the WordPress instance. So here I have a security group, that allows traffic on the port 80, which is HTTP, from everywhere in the world. Egress is I allow my instance to communicate on all ports to all the world. Generally, don't change the egress here. You leave it by default unless you have very strict rules. Here it's another one. It was for testing. So the thing actually that I said to not do it, it's exactly that. Don't do that. Open the port 22 to the world. You should not do that, but you can just put. You should actually replace your IP address inside here with a /32. Okay, so IP address /32 to declare your IP address. Here I use a SSH key in order to log in your instance. So I use my private SSH key, my public SSH key, sorry. And here is the instance. So for the instance, I use a small instance type. I define which subnet I want to put this instance. Okay, so I use the AZ2. I want to associate a public IP address with this instance, otherwise will not be accessible from internet. Also define which key I want to use, which security groups I want to use. So I can use several security groups per instance. I think the maximum is 5. Some tags, and here is where we install WordPress. Here is the user data. The user data, I just run WordPress using Docker because it's faster. Okay, I don't want to install Apache and then deploy the zip file of WordPress and then just run Docker. It's easier. So yeah, basic Docker commands, and here it's like the same thing we saw in the previous course for connecting the database automatically. So this is done via environment variables that I will pass to the user data. So if you are in a very secure environment, this is not the good way to do it. You should use SSM, Secure Management Secrets, something like this, AWS SSM, and have a profile for the instance to allow to fetch the credentials from SSM. We're going to see that on a different lecture, not now. But remember this, if you are running in a very strict environment, this is not very good, because if you go to the AWS console and you go to the instance, you can see actually the credentials. So for example, if you have like multiple teams running, accessing the AWS console, and you maybe don't want them to see your password for the database. So for example, here you see instance settings and view change user data, and you can see actually here there is the password of WordPress, and this is clear text, and this is not very good. Okay, and to deploy this code is quite simple. Just run make deploy in this folder. Okay, not in Terraform, just in this folder. And actually what we'll do is just run Terraform. I will do that actually. So here I said make, take the first target, so make deploy. Initialize Terraform, and then he asks you, I want to create this resource, etc., etc., etc. And at the end of this, here he says, there is 21 resources to add. Do you want to continue with this action? And you need to enter yes. And then when you enter yes, it creates all the resources. And as you can see, to create the database instance, it takes a while, 10 minutes, 40 seconds. Okay. And the database instance is created after 37 seconds. That doesn't mean that it's running after 37 seconds. That means it's created and then it needs to boot, to run Docker, and etc. So leave it like 2 minutes before trying out. Okay, guys. So I hope you enjoy this mini course. We're going to continue on different series, how to improve this current architecture, how to make WordPress more resilient, how to make WordPress more fault tolerant, and how to make it faster and more secure. So stay tuned if you want to know how to run WordPress in production ready environments, and see you next time.